All right, hello, my eighth graders. Today is Friday, April 3rd. Today, what you're going to be doing is lesson 20, which is titled What is Force? It was one of the packets or one of the readings in the packets that I sent home on the 16th of March. You are not to do the packets. They are going to kind of be filled in here and there in between our iQuest lessons. You will not do the packet. I will put a Google form or share a Google Doc or something to have you just answer questions on that instead of doing the entire packets. So we're going to be looking at just the first part of lesson 20 today, which is what is force. So I do have a Google form up on the classwork tab for today, Friday, April 3rd. And if you want to read it on your own, you can't find your packet, there are pictures attached to the classwork tab for lesson 20. So there's pictures there of the reading, or if you want to just kind of stay here, I'm going to read it out loud. So if you want to listen to it and see me, you can. Okay. If not, just complete the Google form, submit it, and that is all for today. Makeup work as usual, and the marking period is over. Third marking period is over. I need work like ASAP to update your grades for the third marking period. So what I'm looking at is the What is Force packet. Okay, so it talks about when you ride a bike, your foot pushes against the pedals. The push force the wheels to turn. When you drop something, it's pulled to the ground by gravity. We know that. That's how we stay on the Earth's surface. We don't float in the air. To turn a page, you first pull it up, then you push it down. Okay, so I pull it up, I push it down. Scientists call a push or a pull a force. A force is a push or a pull that changes the motion of an object. Some forces are very weak, others are very strong. For example, only a slight force will turn this page. More force is needed to pedal a bike. A much greater force is needed to lift heavy objects or to make a car go. We see that force can make things move. A force can even do more. A force can also stop. It can change the speed and or change the direction of something that is already moving. A force can act in any direction. Forces are measured in units called newtons. Newtons are named after Sir Isaac Newton, who was an English scientist who studied motion and gravity in the 1600s. What happens to a moving object when no new forces act on it? The object will continue to move at the same speed in the same direction. This characteristic of matter is called inertia. Inertia is the resistance of an object to change its motion or lack of motion. All matter has inertia. So that is the first page of your packet. Okay, then I'm going to skip over to the next reading section, which is on gravity. Has our little astronaut there. Okay, so it says, when you drop a book, it falls to the ground. Why does this happen? The earth pulls on the book. The earth pulls on you. The earth pulls on everything. The measure of how much the earth pulls on you is called your weight. All objects pull on one another. This pull of force is called gravity. Every object has its own gravity. You have gravity, so does a piece of dust. Even a tiny atom has gravity. However, these pulls are too weak to be measured. Usually, a larger or more massive object has a stronger gravity than a smaller or less massive object. The pull of the moon's gravity is less than the pull of the Earth's gravity because the moon has less mass than the Earth. Therefore, the moon's gravity is weaker. It pulls with less force. Since the moon's mass is 1/6 of the mass on Earth, you would weigh about 1/6 as much on the moon as you would weigh on the Earth. In outer space, you would be very far from both Earth and the moon. The pull of gravity would be zero. You would be weightless. Your weight would be zero. You would just float around. So that would be kind of cool to do maybe for a day, right? All right, and then our last page that we're going to do is the one that has the shuttle. Okay, it says T minus 10 seconds and counting to lift off. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Blast off. The space shuttle is launched. Hot gases are forced out the back of the shuttle. In addition, these gases exert an equal and opposite force on the shuttle. Every action is always met with an equal and opposite reaction. You experience action and reaction forces every day. When you push against the table pushes against you as well. If there were no reaction forces, rockets like the space shuttle would never work. All right, so force, action, and reaction. We have Newton's, Sir Isaac Newton, and gravity. So we got lots of good stuff here. Okay. So again, log into Google. Go to, well, you're already there if you're seeing me. Go ahead and click the classwork tab, and you have your assignment there for today. Okay. So happy Friday. I have nothing really for you for the weekend. So if you have makeup work to do, that would be great because the third marking period was officially over the other day. And we are in the fourth marking period, but I still need some work from some of you. So I want your grades to be as best as they can be. I hope you are all well. I hope you are all healthy and safe. And I will see you again soon. All right? I miss you. Take care.